Good morning, students. Now we are studying the chapter structure of atom, and in this chapter, this is my second session. And today we are going to learn about the Bohr's model of atom and what are the postulates given by the Bohrs regarding the model of atom. So, in our previous session, we have just seen the historical approach regarding the explanation of the atomic structure. In that, the various scientists, John Dalton, J.J. Thomson, Rutherford, they had given their concept regarding the structure of atom. John Dalton, his concept is called solid sphere model. Plum pudding model was given by J.J. Thomson. Rutherford has given the nuclear model of an atom. So now today we are going to learn about the Bohr's model of an atom, and it was given by Niels Bohr. Okay, so Niels Bohr has given the structure of atom in year 1913, and it is called planetary model of an atom. And then after learning about the Niels Bohr model of atom, we will study about the quantum model of an atom. But today we are going to study about Bohr's model of an atom. So what are the postulates given by Niels Bohr in his planetary model of an atom? The first postulate is electron revolves around the nucleus in discrete circular orbit called a stationary orbit without emission of radiant energy. It is very important point because in Rutherford model of atom you studied that the electron is revolving around the nucleus, and according to the electromagnetic theory of radiation, it was said that the charged particle which is in accelerated motion should radiate energy, should release energy in the form of radiation. But here the first postulates, which is very important, gives idea that electrons are revolving in discrete circular orbit. Discrete circular orbit means the orbit in which electron is revolving having fixed energy level, and these energy levels are called orbits. Okay, so unless or until electrons changes its orbit, energy is not released in the form of radiation. So now the second postulates, the angular momentum of an electron is quantized. Now the most important is here to understand the concept of angular momentum. When a microscopic particle like an electron is revolving in circular orbits, so it has momentum, and you know that the object moving in circular path, its velocity is changing at each and every point. Just let us understand this concept. Suppose if an object like an electron is moving on circular path, then it has some velocity with which it is moving. From radius it has distance r. So in case of circular motion we talk about the angular momentum. Okay, and in case of linear motion we talk about the linear momentum. You know that linear momentum p is equal to m into v. You already aware about this fact. Now angular momentum is represented by L, and L is equal to I into omega. Now this I is called moment of inertia, moment of inertia, and it is equivalent to the mass, and omega is called angular velocity. It is angular velocity. Omega is angular velocity. Okay, now just see here, object moving in linear path having linear momentum, and its momentum is called linear momentum, and object revolving on circular path having angular momentum. Okay, so angular momentum is equal to L is equal to I into omega. Now I is called moment of inertia, and I is equal to mass into r square, mass of the object, and r is radius. Radius means distance from the center, and omega, angular velocity, is equal to linear velocity by r. So putting the value of I and omega in this equation 1, we will get angular momentum L is equal to m into r square into v by r. One r is cancelled out, so you will get mvr. So my dear students, angular momentum is equal to mvr. So if an electron is moving at a distance of r from the center, having velocity v, and the mass of electron is m, then the angular momentum will be mvr. So what was the postulate? Second postulate is going to be very important. All the orbits are not possible. All the energy states around the nucleus is not possible. Only those orbits in which angular momentum is an integral multiple of h by 2 pi is possible. So mvr is equal to n dot h by 2 pi. The angular momentum of an electron is quantized. Suppose if it is the first orbit, the value of n is equal to 1. If it is the second orbit, the value of n is equal to 2. So for each orbit, for each energy level, you are just saying that the angular momentum is quantized. It is a very important term, quantized. Quantized means at different level the value is different. You can understand the concept of quantized with this picture. Suppose you are just going at the point A from this point B, and it is point B and it is point A. Now in this case, if you are at this position X, at this position Y, at this position Z, your distance from the ground surface is different. For Y it is h1, for Z it is h2. So you know that the potential energy will be different at every position. So this is the case of, this is quantized situation. Energy is quantized. But when you are in the left, just in that case energy is not quantized. Okay, so quantized means energy is different for different level. So my dear student, the first postulate, what said it? It is said that electrons revolve in the discrete circular orbit. Now the second postulate confirm that only those circular orbits are possible, only those circular orbits in which angular momentum is an integral multiple of h by 2p is permitted. Okay, so I hope these two concepts, these two postulates are very much clear to all of you. So now moving to the third postulates. Okay, according to the according to Bohrs model, the third postulate is when an electron makes a transition from its non-radiating orbit. What do you mean by non-radiating orbit? It means electron is present in its stationary state. A stationary state means the permitted orbit in which it should have occupied its position. But suppose if an electron is present in first orbit, now after absorbing radiation it jumps to the third orbit. When electron changes its orbit, there is transition in orbit change. In that case only energy change take place. So in order to go to the higher energy level, electron absorb radiations, and when it returns back to the lower energy state, energy is emitted, or you can say that photon is emitted. Okay, so these two concept, three postulates are very important. What is the first postulates? told by Niels Bohr that electron revolves around the nucleus in discrete orbit called a stationary orbit, and unless or until electron is revolving in that particular orbit, emission of radiant energy does not take place. And only those circular orbits, only those stationary orbits, only those energy levels are possible for an electron in which angular momentum of electron is integral multiple of h by 2 pi. It means angular momentum of electron is quantized. Okay, these 2 points are clear. And third point is, when in an electron makes a transition, it goes from one energy state from one orbit to another orbit, then in that case only energy changes. Suppose you are the student of class 11th and you want to go to the class 12, so energy level is different. In order to get admission in the class 12, you should have the knowledge of that class. So for transition, more energy is required, more knowledge is required. Okay, so these are the postulates, and on the basis of these postulates, as you know that as for Planck's quantum theory, E is equal to h nu. Suppose E1 is equal to h nu, Et is equal to h nu 1, h nu 2. So you can say that while changing in the orbit state, the energy change, and we can calculate the difference in energy level also. So very important concepts which are derived from the Bohr's model of atom regarding for the theory for the hydrogen atom. According to Bohr's model of atom for hydrogen atom, these are the concepts we have discussed. So now according to Bohr's theory for hydrogen atom, stationary state for electron are numbered by n is equal to 1 2 3. These are the orbits, and radius of stationary state is expressed as Rn is equal to n square a0 a naught, where a naught is equal to 52.9 picometer. 1 picometer is equal to 10 to the power minus 12 meter. So this is an expression to find out the radius of an orbit. Using this formula Rn is equal to n square a naught, you can easily find out the radius of an orbit, where a0 is equal to 52.9 picometer. Okay, and these all formulas has been derived, but at this level it is not discussed. The details regarding the derivation of energies of the stationary state, radii of the orbits used by Bohr is little bit complicated, and it is not derived here. Just we have to remember the formula which was used to calculate the radii of an orbit, to calculate the energy of an electron present in an orbit. Okay, so radii of a stationary state is given by Rn is equal to n square a naught. A naught is equal to 52.9 pm, and 52.9 pm, pm means picometer unit, and 1 picometer is 10 to the power minus 12 meter. And this a naught having value 52.9 is called Bohr orbit. Okay, is it clear? Now this is the general formula. Rn is equal to n square by z into 0.528 angstrom. Now the angstrom and picometer, what is difference? 1 angstrom is equal to 10 to the power minus 10 meter, and 1 picometer is equal to 10 to the power minus 12 meter. And so when the unit is converted if picometer is converted into angstrom, you will get 0.528 angstrom or 0.529 angstrom. So this is the general formula to get the radius of an orbit. What is that formula? Rn is equal to n square by z into 0.528 angstrom, or you can say that radius of an orbit n square is equal to z is equal to 0.529 angstrom. This is the formula used to get the radii of an orbit, nth orbit. N is equal to, suppose the third, it means you are talking about the third orbit. Z is atomic number. Is it clear? Here Z is atomic number, so you should remember this formula also. Okay, now just we are talking about the, we have talked about the radius. Energy of a stationary state. A stationary state means energy of an orbit. Suppose an electron is present in the first orbit, an electron is present in the fourth orbit, then how will you calculate the energy of that orbit? Bohrs had given us a formula regarding the energy of an electron in a given orbit. En is equal to minus RH into 1 by n square. Okay, so here RH is called Rydberg constant, and its value is given by RH is equal to, its value is 2.18 into 10 to the power minus 18 joule. Okay, so in order to get the value of energy of an electron in a given orbit, nth orbit, you will use this formula. En is equal to minus RH 1 by n square. But here 1 is atomic number for hydrogen atom as given by the Niels Bohr. But suppose if we have to apply this formula for other element having atomic number 2 or 3, then this formula is changed as En is equal to minus 2.18 into 10 to the power minus 18 Z square by n square joule. Is it clear? Okay, so for any orbit you can apply this formula. Suppose if you want to get the energy of third orbit, then what will you write? E3 is equal to minus 2.18 into 10 to the power minus 18, and if its atomic number is 1, then you will write 1 square by third orbit, then 3 square. You will get the energy of electron in the third orbit. If you want to get the energy of electron in the fifth orbit, then at the place of n it will be, it should be written 5. Okay, so this is the formula. There are two formula we have discussed. One is regarding the radius, Rn is equal to, okay, radius, regarding radius I have just talked to you. Radius is equal to Rn is equal to n square by z into 0.529 angstrom. This is the formula for radius of an electron present in nth orbit. For energy, En is equal to minus 2.18 into 10 to the power minus 18 Z square by n square joule. So these are the two formula to get the energy and radius of an electron in the nth orbit. Okay, so now just we have talked that as per the Bohr's model of an atom, unless or until there is transition in the position of an electron, if electron changes its orbit, it goes from lower energy level to higher energy level, or comes to from higher energy level to lower energy level, there is no change in energy. Okay, so this formula is used to get the energy of an electron in a given particular orbit. Suppose if there is energy gap between two orbits, so how do we derive the wave frequency of the radiation emitted or absorbed? Okay, so now the energy gap between the two orbit is given by delta E is equal to EF minus EI. EF matlab, EF means final energy state, EI means initial energy state. Okay, so now apply the energy formula. Just we have studied En is equal to minus 2.18 into 10 to the power minus 18 Z square by n square. Okay, so here this is minus 2.18 into 10 to the power minus 18. Just we have talked that 2.18 into 10 to the power minus 18 is Rydberg constant. So what can you write? You can write this formula: En is equal to minus RH by NF square. Suppose Z is equal to 1. If we talk about the hydrogen atom, then Z is equal to 1. Okay, so now you can, how can you write? You can write delta is equal to, for EF, minus RH by NF square minus RH by NI square. So now this formula can be written as RH is taken as common, so delta is equal to RH 1 by N1 square minus 1 by NF square. Okay, now put the value of RH. Delta is equal to 2.18 into 10 to the power minus 18 joule, 1 by N1 square minus 1 by NF square. So this is the formula to calculate the energy required for changing the orbit. Suppose if electron jumps from first orbit the fifth orbit, it means the final NF is equal to 5, N1 is equal to 1. So what is the energy gap between these two orbits? You can calculate by this formula. Delta E is equal to 2.18 into 10 to the power minus 18 joule into 1 by N1 square minus 1 by N2 NF square. So this much of energy is required to change the orbit. Okay, so if once you got the value of energy change required, energy gap between the two orbits, it is easy to calculate what will be the frequency of the radiation required for this energy change. You know that E is equal to h nu, so you can say that delta E is equal to h nu, or you can say that nu is equal to delta E by h. Okay, so now what will delta nu is equal to delta E by h, and the value of delta E is equal to RH. Just I have written for this quantity 2.18 into 10 to the power minus 18 as RH by H. Okay, is it clear? So what do you get? You get, putting the value of RH and H, if the value of RH Rydberg constant and the value of H Planck's constant is put here, we get finally nu is equal to, frequency of the radiation is equal to 3.29 into 10 to the power 15 into 1 by N1 square minus 1 by NF square. This is the frequency of radiation required for the energy gap. Very simple question is asked: what should be the frequency of radiation required to change the position or change the orbit of electron from first to fifth? Use this formula. Now you can also calculate wave number. You know that wave number is equal to nu by c. So put the value again. What do you have to do? You have just calculate nu is equal to RH by h. Just divide it by the value of speed of light, 3 into 10 to the power 8 meter per second. You will get 1.09677 into 10 to the power 7. The value of, when you will solve this quantity, you will get this one. Okay, it is in per meter. So finally nu bar is equal to 1.09677 into 1 by N1 square minus 1 by N2 square. Actually it is N2 means final, NF you can write also final, and this is called Rydberg constant again. You have studied about this in case of hydrogen spectrum. So I hope all these points are clear to you. So there is one very important question: why are you using minus, negative sign with the energy? Just we are writing En is equal to minus 2.18 into 10 to the power minus 18. Okay, just we are using this term joule. Suppose that 1 by N1 square and it is joule. So why this minus sign is used here? This is a very important question. Why does the negative electronic energy? My dear student, suppose that a free electron means electron is at infinity. It is not in the influence of force of attraction of nucleus. In that case its energy is 0. When the electron is free from the influence of nucleus, the energy is taken as 0. Okay, and when it approaches near to the nucleus, in that case what happens? Electron is attracted by the nucleus, and when it is attracted by the nucleus, then energy is emitted and energy is lowered. So when energy is lowered, its values from 0 becomes negative. So in order to make the quantity positive, we use the negative sign. Is it clear? Okay, so what we learned today, the today session is very important, and just I am concluding all those points. Today we learn that as per the Bohr's model of an atom, electrons revolve in a permitted stationary state, that is called cell, that is called orbit, and only those orbits are possible in which the angular momentum mvr is integral multiple of h by 2 pi. This is the first concept. Secondly, we studied that we can easily calculate the radii of an orbit using the formula Rn is equal to n square by z into 0.528 angstrom. This is the formula used to calculate the radii of an orbit. And third and important point to be calculated, the energy of an electron in an orbit is calculated by using formula En is equal to minus 2.18 into 10 to the power minus 18 z square by n square joule. Okay, this is the third formula which was very important. And finally, just we studied that we can also calculate the frequency of the radiation required for the change or energy gap between the two orbits, and that is calculated by energy gap. First energy gap is calculated by using formula E delta is equal to RH 1 by n1 square minus 1 by nf square, and just remembered RH is equal to 2.18 into 10 to the power minus 18 joule. It is the Rydberg constant. So this formula is used to calculate the energy gap between the two orbits, and in order to calculate the frequency of radiation required, nu is equal to 3.29 into 10 to the power 15 1 by n1 square minus 1 by nf square hertz. So use this formula to calculate the frequency of radiation required for the transition of an electron from one energy level to another energy level, or when an electron jumps from one energy level to another energy level, then what would be the frequency of the radiation emitted. So my dear student, these are the 5 formula, very important, just we studied today. And on the basis of these 5 formula, you should solve some numericals given in your NCERT book, and when you will solve the numericals, you will get clear cut concept. So okay, I hope all the topics had been clear to you. So now I hope topics had been cleared. So thanks for watching, and like and subscribe the channel. Today I explained all the topics in English. So I hope if there is a problem in understanding, you can convey your message. Okay, thanks. Have a nice day. Like and subscribe my channel. Log into my blog also. Thank you.